Hi and welcome to Concept-Based Tutoring. I'm John Hepworth and this is video number 1. So hopefully in the future I'm looking back at this video after I've posted thousands of videos and probably cringing at the formatting and the color and my writing on the board. But we have to start somewhere. So here we go. Video number 1. So I'm starting with Year 11 Advanced Mathematics here. So if you're a Year 10 student or a Year 11 student who came out of the path now, Year 10 area, went pretty well at maths and are doing Maths Advanced or Maths Extension 1, what I want to talk about is some of the things that I've seen students struggle with coming into Year 11 and doing this algebraic techniques topic that is so often the first part of Mathematics Advanced in the working with functions section. And the students that I have come into Year 11 struggle with algebra when they really can't link a lot of things together. And in this algebraic techniques outcome of your syllabus, one of the dot points in there says solve quadratic equations by factorization, completing the square, and using the quadratic formula. So there's actually 3 methods there. Now, I think that you need to be able to go beyond those 3 methods and have a conceptual understanding of what method you actually should be using. So I've put this equation up here on the board, solve x squared minus 3x minus 4 equals 0, as a sort of taste of what I'm talking about for you. Because if you look at that question and you've solved it already, and the way that you've solved it already is very particular, or one of those options that was mentioned in the syllabus, then my question would be is, could you do it the other ways? And then beyond that, could you even extend it into something more that relates to it as a function? In Year 10 path, you would have done nonlinear graphs, and some of those nonlinear graphs that you would have done would have been parabolas. And you could think of this equation as a function, and it is a parabola. So what I want you to be able to do is I want you to be able to link a range of concepts together when you're doing your mathematics. So let's have a little look and see what's happened, in relation to the question. If you've paused the video and you'd had a crack at it, or if the first thing you do when you see videos like this is just like, oh, I'll let the person talk, but I'm just going to solve the question and I'm done, then you're exactly the student that I want to talk to, because maybe there's more that you could be able to do with your understanding. So the students that I really want to speak to the most here are students that just went and cranked out the quadratic formula. So if you look at a quadratic like this, and the first thing you think is this, I know the quadratic formula, so I'm just going to go for it. And the quadratic formula is on the formula sheet, so you can just copy it out, fill in the blanks, and be done. Yeah, I really want to speak to that student, because I've got some questions to ask first and foremost. Before you went and just plugged these numbers into the quadratic formula, did you ask yourself, is this equation actually solvable? Or did you think, I'll just plug it into the formula and see what happens, and if we run into any problems, then maybe it's not solvable? And the reason why I'm asking that is because I want to try and have a method occurring that's checking your algebra as you do it. Now, if you just go and plug into a formula, you essentially have no way of knowing whether you have plugged into a formula correctly or not when you're going through a test. You either have or you haven't. You've either made a numerical error, or you've made a copying error, or you've made some sort of negative error, something. You've done something wrong, but you don't know. You have no way of knowing, because unless you go and actually do the working all over again, which we don't want to have to do. So what I want to have happening at the same time as you are doing these substitution into formulas is that there's some sort of fault checking system that's going on in your head, because you understand more of the concepts of this question. And so if you run into a particular solution, you would think to yourself, oh, that seems right to what's going on here. So for example, say we went and plugged into the quadratic formula here, and we got no real solutions. We found out that our discriminant was negative, and we therefore just went ahead and wrote, well, therefore no real solutions. is there anything in this question that you can see that would identify that you're wrong, in that you've made a mistake there in your calculations? Okay, so let's get to the crux of it. This is what I'm talking about. So when I look at this quadratic equation, I look at it and I look that the leading term is positive, so it's a positive happy parabola, hands in the air, and it has a y-intercept that's negative. It has a negative 4 y-intercept there, that constant term at the end. So I know that if I was to draw a parabola, now this is, I don't know what the parabola looks like, but this is just parts of it. I know that if I have a y-intercept that's at negative 4, but my parabola is positive, then I know it actually has solutions. So it's only by thinking of this algebraic question as a functions question, nonlinear graph from year 10, that I have any sort of fault checking system against my numerical calculations. And that's what I want you to have. I want you to be always have more than one method to know that what you're doing is right, and have a deep understanding of what's coming out of your calculations to make sure that it makes sense. So if we look at this graph here and see that we have two solutions, we now have an indicator to tell us that our calculation of b squared minus 4ac must have been wrong. Now, the most common thing that students do wrong when they do a calculation of b squared minus 4ac and get some sort of error is that they have they've had an issue with the minus 4ac. So, we're just subbing into the quadratic formula. That is a discriminant part of it. Actually, let's just do the inside of that square root, the b squared minus 4ac. The major issues that students will have is that when they substitute either in A or in C, and in this case, in the case of the C term, where it's a negative term, they won't have substituted the negative in here, and therefore this negative that is in the discriminant will remain negative. But if you put a negative in there, then obviously a negative times a negative is going to make it a positive, and you're going to end up with some positive answer in the discriminant, which will give you the two solutions. But if you don't, then you may not. So for example here, if I made this error and I just went, well, b squared, so negative 3 squared minus 4 times a is 1 times c, I'm just going to put in 4, right? Not negative 4. So now we've got 9 minus 16, and we get negative 7. And so now we now have no solutions because we have a negative answer. And so we think that this quadratic isn't solvable. We say no real solutions, and we just move on. We move on without having some sort of, again, some fact-checking, some conceptual understanding that we should have grasped when we first looked at this question and just went, oh, this definitely does have two solutions because it's a happy parabola, positive leading coefficient, and it goes through a negative y-intercept, so it has to have these two solutions. So I've made some sort of error, and that would lead me to come back and check, and hopefully when I come back and check, I can find that I've made this substitution error here, this times by 4, it should have been times by negative 4. So I've used now a conceptual understanding to double check my algebraic calculation. Now on top of that, if you are a student that just grabs a formula straight away, I would love if you could just change that up a little bit. Please have a crack at the cross method or PSF method first. Why? Why, Mr. Hepworth? That makes no sense. It's slower. I know I'm going to get to the solution by just using the formula. Why would I ever think about using some sort of factorization technique, some null hypothesis to get to the solution, when I can just crank out the same process over and over and I know I'm going to get there? Again, it's because there's a linking to a range of different concepts that can be going on. Later on, when you're doing, say, integration, and in the integration, you might need the form of the function to be a particular type. And the only way that you can make that function be in a particular form is by factorizing the denominator of the function. Now, if you aren't practicing PSF all the time when you're doing your quadratic formulas, when you're doing a quadratic equation, then your chance of recalling it correctly all the time when you need it is minimized. So I would always recommend students start off with PSF or cross method, whichever factorization you prefer, before going straight for the quadratic formula, because then you're practicing skills for other situations inside the question at the same time. And the factorization question doesn't become something different or unique that you specifically have to do. It's just part of your understanding of parabolas, part of your understanding of quadratics as a whole conceptual understanding of how these functions or equations work. So, if you are going to go and do a PSF method, hopefully you're aware that we're looking for something that multiplies to give the last term and adds to give the second term. And so if we're timesing to get a negative, one of our factors is always going to be negative, another one's going to be positive. It's the only way we can times two things together to get a negative. And we want them to add to give negative 3. So in this case, we find negative 4 and positive 1. And so therefore, we go ahead and factorize our quadratic. And we write it like this, which leads us to solutions of x equals 4 and negative 1. Now, hopefully, that last little step that I made, there was another concept that popped up for you. How is it that I'm going from x minus 4, x plus 1 equals 0 straight to the solutions, and why are they opposite to the factors? So, the idea here is that we are trying to find something that where two terms are multiplying together, two factors are multiplying together, and they equal 0. So the rule here is that 0 times anything is 0. So therefore, if this part was 0, the whole thing would work, because this could be, say, 0 times anything, 0 times 7. What's 0 times 7? It's 0. So as long as this is 0, it would work. And in the same situation for the other side, as long as this one was 0 on its own, then it would work. So I'm just trying to make this equation work by making one part of the multiple 0. And how do we make x minus 4 equals 0? So we do that by making it the opposite of the factored terms that we were looking at. Because if we just add 4 to both sides here, we get and find this 4. Similarly, we find that negative 1 from the situation of the other factor. So, if you're a student who just looked at this quadratic equation at the top and went, I don't need this video because I know how to solve quadratics, whacked it in the quadratic formula and got 4 and negative 1 out, awesome. That's great. You can solve quadratic formulas. But that's not what I'm about here at Concept Based. I want you to be able to have as many things going on for you in one question as possible, so that you can have fault checking, you can have links to other topics when they come up that you can use easily, and that you have a range of tools available for you in case the question isn't as expected, so that you can do deeper, harder understanding questions. This question here has very, very little depth. It's 100% just a skills-based question. I'm not even sure in terms of the band where I would place solving a quadratic like this. Like using a formula substitutes in doesn't apply it in any way. Band 2, of an outcome of this sort of question, maybe band 3. But what we're looking at is we want to get you in a situation where band 6 understanding in this course is available to you, and it's not a long way away, even in a question that is incredibly skill-based like this. I've turned an algebraic equation into a function, and then into an image, and then into an understanding of the two roots having to exist, and therefore knowing that my discriminant has to be positive. I've got this whole application understanding of this quadratic equation into nonlinear functions, and being able to solve therefore more questions. Also looking at this, it's a positive parabola, so I know at some point on the parabola there's a lowest point. And I can see here that lowest point is below the x-axis, and therefore my y value is going to be some negative value. If I was being asked, hey, if we were looking at this equation, what would be the minimum value that we could get to if we didn't want to set it to 0? How far down could we go? And again, you might look at that or listen to that question and think, Oh, well, that's axis for symmetry and then substitute in. Great. I'm glad that you know formulas and you know how to find those solutions, but I want you to have the conceptual understanding at the same time. I want you to be able to know that that answer is going to be negative before you go ahead and substitute into the formula to find what that is going to be, because you have a way of cross-checking your understanding. Okay, so I know this is a long video for where are we up to? 15 minutes for just solving a quadratic equation. Obviously, I don't want you to be using this sort of really drawn out, long-winded thinking when you're doing a question. But what I do want is I want something. I want some sort of cross-checking method. So, look, would I draw this image here if I was solving a quadratic equation in a test? Probably. As a teacher for 20 years, if there's anything that I tell my students more than anything else, is if you can draw a picture, then do draw the picture. And without drawing that picture, there's no way you could know that your discriminant was wrong. Generally, you could know positive parabola has a negative y-intercept, but I mean, that's what I'm drawing there. So by drawing that picture, you just have that fault checking already up there and in place. So I would recommend at the start of a question, if you could get a rough graph of that nonlinear equation out, just to sit there while you're doing the algebra, then I would do it, because I think it's very helpful and it has a better understanding, so that if the question becomes more complex, maybe there's a part B, you already have a deeper understanding of what's going on for this function. If you would like to have any sort of tutoring that's along the lines of having this conceptual understanding, if you are a year 11 student who's just come out of year 10 path and starting year 11 advanced, then please contact me, info@conceptbase.com.au. It's not just advanced. If you're an extension 1 student, then all good as well. And if you're in year 12, no problems also. Just reach out, and I would love to be able to help you have a deeper understanding of the concepts that are in your course.